So for me, it's very important that when I think about function calls, I always think about these stack frames, and each stack frame is simply just an area of memory dedicated to each function so it can allocate its local variables. But today I would like to discuss the arrays specifically. A question? No? Okay. So moving on with this array situation that we have. One thing that I'd like to show you is I actually would like to show you a number of things with arrays being passed to functions. But one thing is that if inside main you could ask array what its size, and I really haven't discussed with you the Sizeof operator. There's a Sizeof operator, but I don't even want to use it today because that's a separate topic, perhaps for next week or even the week after. But today I would like to tell you that because the arrays are passed to functions only by the address of the first element, they lose the number of elements in the array. So there's absolutely no way for this initialized array officially to know that it's actually an array of 5 numbers. So let's experiment with this. Experiment number 1. Let's do this. Have some kind of a hard-coded loop which will basically use some kind of index starting with 0. Recall that all elements are indexed 0, 1, 2, 3, and 4, right? These are actual indices of these elements. So then, so therefore, knowing this, I can just basically use index is less than 5, which is essentially a standard loop to go over all elements in the array, like this, and assign some new values. Array index equals, for instance, index plus 10. That should initialize elements of this array with values. The new values which we'll be using is like 10, 11, 12, 13, and 14. Okay, so because I'm using index, which ranges from 0 to 4, and index plus 10 is 0 plus 10, 1 plus 10, 2 plus 10, and so forth. So 10 to 14. And so this expression, array with that uses square brackets to refer to individual elements, actually refers, essentially is indirect access to the elements, but indirect access to elements of the original array which is created here in main. So what happens in computer memory that, let me just erase this a little bit. What's going to happen here is array is created as part of main local scope, right? Array is completely belongs to main, but since we found a way to pass this to initialize array, in this loop, what we're going to be doing when initialize executes, it's going to be updating the original elements, right? The original array elements will be updated with new values as a result of us passing array to another function. So arrays are not automatically copied by value, they're passed by the address, and that's what's going to happen. So I can now copy and paste this, right? And say, in fact, why don't I create another function, which would be very kind of useful. right? So I could say print array, print array. Okay, and of course, if I do this, I simply copy it and paste it everything, but I need to remember to go back to my header. In fact, let's pretend that I forgot to go to my header and update and add function prototype. We'll see what kind of error we're going to get. But this time inside the loop, which is, by the way, hard-coded to only 5 elements, right, I will say std cout display array index, whatever that index is, and also add like a space character to separate individual elements. And then at the end of this output, I can say std cout and display new line, just to make sure that I have a clean output. Number one, observation number one. Observation number one is that recall that each CPP file, such as dummy.cpp or main.cpp, are compiled independently. In fact, for us, the programmers, it's impossible to predict when the compiler is going to be compiling, in other words, which file will be compiled first and which one is going to be compiled next. We don't know. The standard says that each one of them will be compiled. Each one of them, if there aren't any problems, will result in producing this object file, which will eventually be linked together with all of other object files and will produce the resulting executable. So, I just was saying, okay, let me do this, right? Let me add this print array function, and so here the comment should be saying print all 5 elements, which is terrible hard coding, but we're in the progress of a series of demonstrations, so that's okay. And I go to my build and say build solution. The first problem that gets reported to me, and you usually go to the first problem, just find the first problem. You can double click in any of these environments, and it's going to tell you, here it tells me that cout is not a member of STD. So essentially, to translate this error message, it says, I have no clue what STD, what cout is. Okay, it just says, don't know. So obviously the problem is that include is in main, but dummy.cpp has no such include. If you scroll this up, it only has my own include my header.h. So realizing it, I may actually take this out or copy it and add it to my header, right? So normally the header guard, then we can place more includes. So just knowing that my header is going to be used for these function prototypes, or inside the actual implementation of these functions, I may just include IOStream directly in my header, and then when dummy is compiled, my header is obviously processed, it contains another include, and everything should be fine. Now, this original problem should no longer be a problem. Now notice that my other alternative would be to place it right here, right? Normally, system include files, directives should appear on top of our own custom header files that we want to include. So I could do it this way. I could do it inside the header file. As long as I found a way to include the right header anywhere inside other header files or directly like this, it should be fine. And of course, including multiple IOStream, including IOStream multiple times in the same translation unit, such as dummy.cpp or main.cpp. If it's part of the same translation session for intending to produce a single object file. This is not a problem because IOStream has its own header guards, right? If we say, take a look at it, the first thing that you see pretty close to the top is this. If not define IOStream, define IOStream, and the rest of it is actually the code of IOStream. So the header guard is on top, and of course at the very bottom, if I press Control-and to jump to the bottom of it, there's your end if for IOStream. So the header guard is part of every header file that we're creating or part of the system, right? So the entire compiling environment is such that it's just simply like combination of all of these header files and source files as a result of the simple work of include, right? The only complication that you can possibly think with includes sometimes is the directory where the files are located, because files could be part of different directories, and sometimes this can be a complication. Rather than that, include is extremely simple. Just find this file and bring it over. Include inside the file.